Hi, this is Ryan Salazar with Broadcast Beat, and I've got a great guy, John Pallett from Telestream. How you doing, John?
I'm good, thank you.
So, our discussion today was going to be a little bit on video over IP. What does that really mean?
It's a term that has a lot of different definitions, and when you're talking about video over IP, it's really important to know what you're talking about. Typically, we've seen it mean one of three things. The first is the ability to send a video signal over the internet to a consumer. For example, sending video to somebody's iPhone or their set-top box in an IPTV deployment. The second thing we've seen it mean is file-based media, where videos are actually stored as files and then they're transferred over Ethernet between systems for processing and delivery. And then the third thing, and this is a little bit newer, we've heard video over IP to mean the replacement of SDI with Ethernet, either internal within a facility or between different facilities. So a lot of different meanings for video over IP. They all use IP, which, as you and everybody knows, is short for Internet Protocol, the core technology that makes transmission of data over networks possible. All of them use IP, but the application and the method in which IP is used is different in all three of those applications. So very important question, because it's important to know which type of video or IP you're talking about.
Okay, and I've heard many times from a lot of folks in the industry, and they all say, we're 10 years behind in the video production or broadcast industry for the transition to IP. And how true really is that really?
I that one puzzles me. Look, there are other industries that have switched from proprietary systems to generic IT, and that's fine. But the answer is no. We are not 10 years behind. Our industry sends more data to more people than any other industry in the world. Period. We're not behind. IP technology is finally caught up. If you think about it, we've been doing mass transmission of data for almost a century. And if you look at the data consumption on the internet with the limited amount of video being sent today, and then compare that to the amount of video that's broadcast and sent over cable and other non-internet systems, it's incredible. The amount of data that this industry pushes out is mind-blowing. So we're definitely not behind. IP is catching up to where we are. And the fact is, we've been doing video over IP for over 20 years. There were pockets of this in the 90s, little islands where systems would talk to each other using video over IP. Some of the first transmission of video, which Telestream was involved with in the late 90s, was done over IP to replace tape-based delivery. NLEs in the 90s accelerated the adoption of video file formats. So again, video over IP started becoming relevant back in the 90s. And what's great is that in the last 5 years, 5 to 10 years, the internet and Ethernet bandwidth are finally at a point where we can deliver live streams in between systems inside the facility to the home. And the computer processing is also now sufficient to keep up with the massive amount of data that's being processed.
What do you think the key elements are of a video over IP transition?
If you look specific to our industry of what some of the key elements are, the number one is really computers. Everybody is moving away from proprietary systems to more generic IT-based solutions. So servers that you can buy from Dell or HP or other server manufacturers. This lowers the total cost of ownership. It lowers the amount of maintenance. And then what runs on those servers is software. Software is a core technology that makes Internet Protocol possible. Software is where all the applications are written, and software is fundamentally more agile, more automated, better able to scale than hardware-based solutions are. When you get that automation, you get that scaling, you get something that is very competitive. So computers and software are really the first key element of video over IP. The second, which is a little bit unique to our business, is the consumer. A lot of the devices that have been coming out over the last 5 to 10 years, a good example of this is the iPhone. The way to get video to that device is IP. So if you want to get to that device, you have to be using video over IP. So consumers with devices that have the ability to consume video over IP, because in our business, it's all about getting data to the end consumer. The last one, and this really talks to the ability to replace SDI with Ethernet, is the flexibility of Ethernet and IP-based routing. When you look at an Ethernet backbone, when you look at any sort of WAN or LAN, uh, what you have is you have a phenomenal routing system where packets can be sent virtually anywhere without having to go in and manually adjust anything. And it does this at scale. IP backbones offer switching and routing scale that are not possible with SDI. You just can't take the new routing and switching requirements of video and throw SDI at the problem. Ethernet interconnects in a way that's way more flexible and more uniform with everything else that's going on in the facility. So three key elements of video over IP are the computers and the software on them, the consumers using video over IP devices, and then the flexibility of the routing and switching that the technology offers.
All right, so all that sounds attractive in theory, but in practice, why are people doing this?
Well, yeah, it's good point. People only do things to save money or to increase revenue, and the ways that you save money using video over IP is really in the transmission and the workflow automation. So you're either going to be using a lower cost mechanism to send video, and a good example of that is using 4G instead of satellite, or you're going to be automating workflows. And a good example of that is getting rid of tape and starting to do things in file-based workflows where computers can move the files around and process them automatically. That's on the saving side. On the revenue side, there's a lot of new IP-based channels and advertising, new distribution endpoints, social media. A lot of the people who traditionally would have accepted tape are now only accepting video that's sent over IP as files. These are all ways that in order to make money, you need to be looking at video over IP. The net result of this, of course, is that if you save money and you increase your revenue, what this means is your margins are higher. And when your margins are higher, you get more pricing flexibility, which makes you more competitive. So really, the reason that people are looking at video over IP is fundamentally increase revenue, lower costs, become more competitive within the marketplace.
Okay, and so what does this transition mean for content owners and broadcasters?
It's a good question. Software, as I mentioned before, is fundamental to video over IP, and software is something where the pace of innovation, because software is more agile, the pace of innovation is much higher than it ever was with hardware. And that's true at the facility. That's true on the consumer side. That's true everywhere in between. If you look at the things that are coming out of video over IP, there are new distribution points, new ways of offering subscriptions, new ways of offering advertising. And that's on the consumer and distribution side. Even internal to a facility, vendors are continuing to compete in software. And this is driving more and more innovation. It's a real explosion of innovation and change, and it's not showing any sign of slowing down. It's almost entirely enabled by video over IP. The key thing is that it's turning into more revenue and it's turning into cost savings. So this innovation is not going to slow down. Take all of that software-based innovation and then add 4K, 8K, HDR, high frame rates on top of it. What this means for broadcasters and content owners is more metadata, more media to process, more destinations to get it to. A lot of the people we talk with are frankly just struggling to keep up and trying to scale their systems to keep up with the pace of change and the number of endpoints that they need to get things to.
So, is there anything that content owners and broadcasters should be doing to prepare themselves for this IP change?
There are, and specifically if broadcasters, content owners don't tackle this problem the right way, the cost of meeting the distribution points can really explode. And we was talking today with somebody who was explaining that when they looked at the cost of setting up 18 different systems to address 18 different channels, the cost made the whole project prohibitive. The good news here is that where software is driving all of the innovation, software can actually help solve the problems of managing it as well. Software is extensible. It doesn't decay. It's not like hardware where you buy hardware and it immediately loses value because it's depreciated. Software can grow, and extensibility is key. So what people need to be looking at is software solutions that can expand and keep up with the pace of innovation. The time of buying something that's purpose built is really at an end. You want to look at the software solutions that can grow and keep pace. That's a general statement, but it's very important because when you have the right software, instead of trying to solve an entirely new entire distribution pipeline, what you're really going to be focusing on is incremental workflow design, hardware scaling, system management, all of the things that you want to be focusing on as you grow business instead of having to solve a whole new problem every time a new opportunity comes up. If you look at different types of video over IP, there are actually different things to look at. So, for example, if you're looking at file-based workflows, what you really want to look at there is a system for automating file-based workflows and automating delivery. This is one where Telestream's Vantage media processing platform has done very, very well. Without a system like that that can take video files, process them, deliver them, manage the ability to send to different channels, but then also be extensible to add new channels very easily. Without that, the assets that you own today won't be ready for distribution tomorrow. So that's one example of something to look at. When you look at IP delivery to consumers, if you don't understand adaptive bitrate encoding, if you don't know what Apple HLS is, then you can't deliver to smartphones. And that's an area where anybody who's thinking about video over IP to the consumer really needs to look at. The last one to think about is as we look at how SDI is going to be replaced by video over IP. This is one where the standard SMPTE 2022, it's having broad ramifications, and there's a lot of active development in this space. So what people need to be doing is thinking about how can Ethernet replace their SDI. It's early days, and so there's a real opportunity to engage with vendors on routing and switching and site layout. In all of these cases, you've got to look at reliability, you've got to look at automation, you've got to look at visibility of the workflows, because you just cannot imagine the work that's going on today being done by tape the way it was 15, 20 years ago.
So, what are some of the key innovations that have happened over the last year in IP video specifically?
If you look at live streaming to consumers, the last 5 years have really eliminated buffering. If you watch video on the internet these days, partly because bandwidth has increased, but largely because the player technology, the encoding technology, the distribution technology is now robust and mature, the last 5 years has really solved the problem of delivering video over the internet to the consumer. At this point, if you're talking about live streaming to consumers, the big innovations are compression algorithms. HEVC is a great example of this, which is really geared to improve quality and lower bandwidth, and also looking at the underlying systems for high levels of redundancy. There's still some work that's going on to get them to the equivalent of broadcast level reliability, but that work is happening, and that's some of the key innovation right now. If you look at the migration from SD to Ethernet or SD to IP, all the standards exist, and now switching is really the innovation that's key. There's been some great switching technology demos recently. Without switching, the rest of it kind of doesn't matter. So it's the key to getting Ethernet to replace SDI. And this is where when we're to keep an eye on the software solutions that are just starting up. So the final area to look at key innovations are file-based workflows. And this is one where over the last 5 years, there's been a lot of work around automating transcoding, automating QC, automating video processing for up conversion and down conversion, standards conversion, all of which is great. The innovation now is largely around automation and scale of the overall workflow. So being able to take thousands of files and have them run through without having to individually touch each one. That's a key innovation that's going on in file-based workflows right now. Having said that, a lot of it boils down to software algorithms. Computers are getting more powerful, and with high performance computing that's available in things like GPUs, there's a lot more horsepower to throw at algorithms. And so just in the last year, we've seen a real explosion of algorithms around standards conversion where you just don't need an SDI device. Retiming, being able to take a 1 hour asset and retime it to 59 minutes or take it to 1 hour and 1 minute. Again, that's an algorithm that's now available in software where you don't need a dedicated proprietary device to do that anymore. A lot of innovation across different areas, but all of it very exciting.
You keep mentioning software, so why is software so important?
Well, I mentioned before, software is really key to internet protocol and the applications that get built upon it. It's really good news for video. As I mentioned before, it's easily updated. The pace of innovation with software is very fast. Software never degrades. Another key thing about software that's sometimes overlooked is that software can easily, uh, it's easy to take software and install it somewhere else. It's easy to take infrastructure that you've built in the software realm and copy it or duplicate it somewhere else. It's makes it very simple to set up and stage systems and test them out completely, rather than having to do it all on site. We actually had a great example of this with BET as they got ready for the BET Awards recently, using the Vantage system where they were able to completely stage the entire environment prior to the event, make sure it worked, and then when it was time for the event, all they had to do was turn it on and they had a working system. You couldn't do that with proprietary hardware 10, 15 years ago. Telestream's got an interesting perspective on why software is important. You'll see a lot of companies in our space talking about how they have software solutions. Well, Telestream's primarily been a software company for over 15 years. And we've really seen the growth of software from 15 years ago with the limited hardware that was available solving small problems. And now it's evolved where software running on IT-based hardware really can become the backbone of the entire facility. So it's been a really amazing change in the software capability and scale that's possible.
A lot of folks talk about, they're using generic hardware, and does the hardware really matter? I'm curious.
It does. We in a lot of applications we've just crossed the cusp of the hardware being able to keep up, and this is particularly true when you look at high performance computing like GPUs. We're not so comfortable beyond what the hardware is capable of that you can ignore hardware completely. The hardware still very much matters. A couple of examples of this: we have our product, the Lightspeed server, and what it is a very tuned server for doing media processing. And what we've seen time and time again is that it will typically run through media files 2 or 3 times faster than off the shelf similar servers. That's not magic. It's nothing about our server that says, oh, it's a Lightspeed server going to run faster. It's entirely because we've sat down and tuned it, mapping the bus speeds, connections to the GPU, the memory speed, getting everything lined up. And the result is that when you do that tuning, you get the full performance of the power. But without that kind of tuning, you really can lose performance. So yes, hardware absolutely matters, especially in situations where you either need to maximize your throughput, for example, in file-based workflows, or where you need to keep up with the number of HD or SD or even Ultra HD streams that you're generating out of your hardware. One other area where hardware really matters is the cloud. And I mentioned the BET Awards a few minutes ago. Great example of how you don't need to have the hardware on premise in order for you to take advantage of it. A couple of nice things about the cloud solutions that are being deployed today. Number one, to a large degree, the hardware is already optimized. Number two, you don't have to buy it. You can rent it and it will be managed for you. So you don't have to worry about the power and the cooling costs and the long term ownership of the system. You can spin it up, set up your system, tear it down, and then go to another location and spin up the exact same system and start using it right away. So hardware absolutely matters in terms of performance, but there are a lot of exciting new capabilities as far as how the hardware gets deployed that are opening up new opportunities for people that previously would have required shipping of hardware between locations.
John, thank you so much for chatting. I love speaking with you guys because every one of your staffers at Telestream, everybody's so knowledgeable about the industry, and I look up to you guys for this information. And so do a lot of other people, especially at NAB and events like that. So, John Pallett, Director of Product Marketing at Telestream, thank you so much, sir.